Hey, Math Journey! Ready to challenge your brain with a fascinating geometry problem? Stick around because, by the end of this video, you'll see how these simple concepts can help us solve a seemingly complex problem. Trust me, you don't want to miss this. Here's the problem we're tackling today. We've got three equations involving three positive real numbers x, y, and z. Let's write them out. The first equation is x squared plus square root of 3 times xy plus y squared equals 25. The second equation is y squared plus z squared equals 9. And the third one is x squared plus xz plus z squared equals 16. And our goal is to find the value of xy plus 2yz plus square root of 3 times xz. Now, before we dive into solving this, take a moment to think about it. What jumps out at you? Can you spot any connections or familiar ideas? Even complex problems often have a simple starting point. Give yourself a few seconds to explore the possibilities, and then we'll solve it together. Sounds tricky, right? But I'm going to show you a method that's not only effective but also quite elegant. First things first, did you notice something about the numbers 25, 9, and 16? They're perfect squares of 5, 3, and 4, respectively. These numbers immediately reminded me of the famous Pythagorean triple, 3, 4, 5. Could this hint towards a geometric interpretation? This triangle clue suggests we might be dealing with something geometric here. But there's more. Consider the fact that x squared, y squared, and z squared are lengths. When multiplied, these might relate to areas. This idea strengthens the possibility of using geometry to solve the problem. Now let's talk about the cosine law, which relates the sides of a triangle to the cosine of its angles. According to this law, if we know two sides and the angle between them, we can find the third side. The formula goes like this: a squared plus b squared minus 2ab times the cosine of the angle equals c squared. Let's see how this applies to our problem. Comparing the first equation with the cosine law, we see that the middle term, square root of 3 times xy, should correspond to minus 2 times xy times the cosine of the angle. Therefore, minus 2 times the cosine of this angle equals the square root of 3. Solving this, we find the cosine of the angle is minus the square root of 3 over 2, meaning the angle is 150 degrees. Applying similar reasoning to the third equation gives us another angle of 120 degrees. Now, let's apply what we've learned to solve the problem. We know that the expression we're after is xy plus 2yz plus square root of 3 times xz. But how do we relate this to the geometry of the triangles we've been discussing? First, let's break it down. We can think of this expression in terms of the areas of triangles formed by these sides and angles. For the triangle with sides x and y and an angle of 150 degrees between them, the area is given by 1/2 times x times y times the sine of 150 degrees. Since sine of 150 degrees is the same as sine of 30 degrees, which is 1/2, this area simplifies to xy over 4. Next, for the triangle with sides y and z and a right angle between them, the area is straightforward: 1/2 times y times z. Finally, for the triangle with sides x and z and an angle of 120 degrees between them, the area is 1/2 times x times z times the sine of 120 degrees. The sine of 120 degrees is square root of 3 over 2, so this area becomes square root of 3 times xz over 4. Now, when we sum these areas, we get xy over 4 plus yz over 2 plus square root of 3 times xz over 4. The bigger triangle has sides of 3, 4, and 5, making it a right-angled triangle because 3 squared 2 plus 4 squared 2 equals 5 squared 2. To find the area, we use the formula. Area equals 1/2 multiple base multiple height. Here, the base is 3, and the height is 4, so Area equals 1/2 multiple 3 multiple 4 equals 6. Thus, the area of the bigger triangle is 6 square units. To match the expression we're solving for, we need to multiply this sum by 4. 4 times xy over 4 plus yz over 2 plus square root of 3 times xz over 4. This multiplication simplifies perfectly to xy plus 2yz plus square root of 3 times xz. So, the answer we're looking for is 4 times the total area, which we calculated earlier to be 6. Therefore, the final answer is 24. If you enjoyed this challenge, don't forget to hit that like button and subscribe to Math Journey for more fun math adventures. Now that you've seen the answer, how did you do? Were you able to crack it? Let me know in the comments. And share this video with a friend who loves brain teasers to see if they can solve it without peeking at the solution.